Hello everyone. So today we are solving 448, which is find all numbers disappeared in an array. So it says that given an array nums of n integers, where num size is in the range of 1 to n. Okay, so we have range 1 to n, so everything is positive. Return an array of all the integers in the range 1 to n that do not appear in nums. Okay, so given an array nums, we have to return numbers which don't appear in this array. So from 1 to n, I see that 1 is there, 2 is there, 3 is there, 4 is there, 5 is not there, 6 is not there. So that's why the output should have 5 and 6. Okay, this looks good. What I can think of one very basic way is let's have a hash set of all the elements 1 to n. And yeah, and I'll go over the nums. And whenever I see a number is present, right? Um, I'll go over the nums, I'll check 4. So 4 is there in my hash set, I'll remove. I see 3. 3 is there, I remove. 2 is there, I remove. 7 is there, remove. 8 is there, remove. 2 is there, remove. 3 is there, remove. So at the end, I'll have only numbers. Then at the end, what I'll have in my hash set is the numbers that were not there in this nums, and I can just add it in my list. So that would be O of n time, because I'll go over the nums array once, and O of n. Actually, I'll go it twice. Once I'll create the hash set, which would be O of n, and the space will also be O of n, and then there's two paths basically. Um, yeah, I think they can solve it that way. Could you do so there's a follow-up which is that says that could you do it without extra space? Yeah, because this was too easy. So they want us to do it without the space. So basically we can't use hash set or some extra space. So usually what you need to think, I feel, is do some in-place array operations when there's no space. So let's see what I can do. So given 4, right? Can I modify this? So we can modify the number at that index. So 4 would be basically 0, 1, 2, 3. So I'll modify this to something. Yes. And then I'll keep doing this. And so the numbers that are missing, right? For those indexes, the numbers would not be. Okay. So yeah, one thing we can do is basically what I'm going to do is for each of the numbers here, I'm going to modify the number at that index to, let's say, a negative number. Yeah, we can do a negative number because it's between the range of 1 to n, right? So what this is going to do is, since I have this array, right? So 4 is going to make this negative, 3 is going to make this negative, 2 is going to make this negative. Okay, so negative 7 is not an index. So when we are taking an index, we need to make sure that we take the positive index. So 7 is going to modify the sixth one. So 0, 1, 2, 3, 4, 5, 6. So this is going to do 8 is going to make the seventh index, which is going to be this. 2 is going to make 0, 1, this. Oh, okay. Another thing to keep in mind here is that if the number is negative, right, and I make it again, so this is going to be positive. But that's the wrong thing to do. So if the number is already negative, I don't change it. Okay, so then you see 3, so 0, 1, 2, that's already negative. 1, that's 0, so I make this negative. So when I go with this array, what I'll see is this and this. Their numbers at this indexes were not changed. So basically for these indexes, the numbers were not present. So 0, 1, 2, 3, 4, 5. So indexes 4 and 5. So that will be basically 5 and 6 for us. And yes, that's our answer. So yeah. So yeah, this looks good. Basically what I'm doing is I'll go over all the nums, right? And the idea here is that I'll calculate a new index, which would be basically the nums at I minus 1, right? But we need to take an absolute value of here of this, because if the number is already negative, like in our case it was for 7, I guess. Yes, so I need to do absolute. So that's my new index. And what I'm going to do it, I'm going to change the nums of this new index to negative. right? But I'll only do this if this nums of new index, if this is greater than 0. Because if it is less than 0, that means I don't want to change it again. And once I have this, right? Okay, let's create our answer list. List of integer answer. That's going to be a new array list. And once I have this numbers, right, what I'm going to do is I'm going to go with this list array again, and I'm going to check if my num is greater than 0, right? That means for those index, okay, I'll need index, so let's change this. So let's change this to this. And what I'm going to do is if nums of I is greater than 0, right? Then I'm going to add that I to my answer, right? But I'm going to add I plus 1 because I is the index and my numbers are from 1 to n. And at the end of it, I'm just going to return answer. Yeah, this looks good. Let's see. Oh, wow, awesome. So yeah, basically that was the idea. So hash set, having a hash set could have been the easier way, but we tried for saving that space. So I went with in-place operations. And in place operations, what I did was given a number. I changed the number at that index to, so given a number, right? I'm going to change the number at that index and make it negative. And if it's already negative, I do not change because that will make it positive. I don't want that. And when I'm doing this, and then go over the array again, and if I see any positive numbers, that means there was no number present in that array for that. So yeah, you add it. In terms of time and space complexity, this is O of n because I go over the array once, and space would be, I'm not using any space. So that was the whole point. So space is O of 1. So yes, that's it. Awesome.